Hi everybody, this is Miss Emily from the Cranston Public Library, and this is Hands-On Science. I'm coming to you live from my kitchen, a wonderful place to do science. In fact, if you are helping your parents cook or clean anything in the kitchen, you're already doing science. This is like your lab. Today, we're using some very simple ingredients, most of which you can't eat, but one of which you can consume safely. So if you want to follow along, here is what you need. You need some paper and something to write with. You need a glass like this one that's clear, a transparent or clear drinking glass. And if you want to do the magic trick I'm going to show you at the end, you need a penny. I have one or two other supplies. Oh, I forgot the ingredient that is safe to consume. Some water. I have a pitcher here. Also, I'm going to be using a flashlight just at the beginning to explain the science concept that we're learning today and that we're going to conduct experiments with. So the scientific concept that we are thinking about is how light travels. You may feel that light is just all around you because it is all around us right now, but all of the light in my kitchen had to travel all the way from the sun. If you look around in whatever room you're in, try to identify the sources of light. So, like I said, there's a window across from me that's letting sunlight in, and that's the only real source of light right now. But if it were nighttime, I would have some of my lamps or lights turned on here in the kitchen. So you can look around. You probably have some lamps or electric lights in your room. Also, electronic devices like my phone that I'm looking at also give off light. So if you have any screens in the room, those could be sources of light. Now, probably you haven't lit anything on fire, but if you did have a candle in the room or maybe a burner on your stove lit, then fire is also a source of light. So take a minute, look all around at these sources of light. As soon as you turn a light switch, if you flick it on, it seems like the light is just there, but it does have to travel. Light is actually waves of energy, particles traveling in waves, and they have to go from the source of light to bounce off an object into your eyeballs, and that is how you see things. You may have noticed that if the lights are turned off at night, it's much harder to see objects. You won't see details like their colors or the texture of the surfaces. Your eyeballs need light bouncing off things for you to know that they are there. So, light travels. It travels so fast that when we say traveling at the speed of light, we mean as fast as possible because light goes really quickly, but it does travel. It travels and it bounces off things into your eyeballs. Let me demonstrate. So, I have a flashlight, woo, source of light. Now, if I point the flashlight down, not surprisingly, you can see the light on the paper in front of me, but that light also will bounce up. So, I have another piece of paper here. Let me just kind of fold it. So you can see when I hold it up like this, you see how this part is in shadow? It's a little dark. If I turn like this is illuminated by the sunlight coming from that direction. But under here, it's kind of like the paper looks almost gray because it's in shadow. Light isn't hitting it directly. Now, if I take my flashlight and I shine it down at the piece of paper, some of that light is gonna bounce up here. See if what I said is true. Yes, right? It lit up a little bit. Even though my flashlight is pointing down, the light hits this, which is above it because it bounces off the piece of paper on the table in front of me. So shadow, a little bit of light. Shadow, a little bit of light. So hopefully you believe me now that light bounces off objects because that is what creates the cool effect that we are going to experiment with today. So if you're ready to do a little experiment with me, as a reminder, you need a drinking glass, some paper, and something to write with. Now, if you want to follow along, what I would like you to draw first is just an arrow. Just a simple arrow pointing in whatever direction you want. Actually, don't have it point up or down, or this will be much trickier. You could rotate, I guess, if you do an up or down. But I'd like you to make your arrow going side to side. So let me go ahead and show you what I mean. So I'm just drawing a simple arrow pointing to the side of me. Okay? So, there's my arrow. So if you draw one like this, then you can try this as well. So now what we're gonna do is we are going to put a glass in front of the piece of paper and see if anything happens. Because we know that light objects, but what about a clear or transparent object? It seemed like light will just go right through, right? So let's try it. Here's my arrow, here's my glass, and yep, light goes right through it. Even when I hold the glass in front, you can still see the arrow. Not particularly interesting so far, right? But next step, I would like you to fill your glass with water. It doesn't have to be all the way up, but high enough that you can put this behind the water. So let's go ahead and put some water in my glass, fill it a little over half full, and let's see what happens now when we put the glass of water in front of the arrow. Now, water, like glass, is transparent or clear, so light can travel through it. I gotta get, oh, there we go. I gotta get the distance right. Remember my arrow is pointing that way, but when I hold the glass of water in front, it's pointing in the opposite direction. How does this happen? Well, ladies and gentlemen, the answer to how it happens is science. So, what is happening? This clear substance, the water and the glass, so two different clear substances, does allow the light to travel through, but it slows the light down. So we said it travels, and it still travels so fast we can't see this difference in speed, but passing through the glass and the water slows the light down and bounces it around a little, not as much as something solid, but bounces it around just enough to change the image before it hits our eyes. This is called refraction, the bending of light beams or light, or the waves of energy, the particles traveling in waves that make up light. So refraction is the answer to why, when your arrow is clearly pointing one way, pass a glass of water in front and it will point in the opposite direction. Let's try a few others for fun. So the arrow works really well to just kind of simply show you what's going on. Another thing that's fun to do is to try writing backwards. I just enjoyed doing this in general. So see if you can get your brain to work in reverse and write your name backwards. So I'm gonna write my name, and I'm gonna write it from right to left instead of from left to right. Okay, my name's Emily, and there's Emily backwards. Let's pass the glass of water in front. If we line it up correctly, now it says Emily going forwards. Excellent, just what we wanted. Okay, another fun one is to do a face with eyeballs that are pointing off to one side. So let's make another picture. So draw a smiley face or a face. It doesn't have to smile, I guess. So a circle and with two kind of big eyeballs, and then I want you to draw the pupils of the eyeballs so they are clearly looking off to one side. You can add a mouth, ears, hair, whatever you want to make your face look kind of funny, but make sure you put the pupils on the eyeballs looking to one side or the other. So here's mine. Did yours come out good? And let's pass the glass of water in front, and what? He's looking the other way. He's looking one way, and he's looking the other way. Looking one way, looking the other way. So that's another fun one to do. So, to review, this cool effect where you can reverse or create the mirror image of something by passing a glass with water in front of it is due to refraction. And a much simpler way to show you just refraction is if you've ever put a straw in a glass, you can see how once it hits the water, the angle changes a little. What you're seeing doesn't seem to line up. That's because when light passes through both the glass and the water, some of that light gets bent. The speed that the light is traveling changes before it hits your eyes. And so You can get this more extreme depending on, or less depending on the angle. Oops, see, I can almost line it up. There we go, that's pretty extreme. But the water and the curvature of the glass helps us a little here, but the water bends the light and it creates this interesting distortion or this weird effect. So, I promised you a magic trick. So, let's demonstrate. For this last part, you will need a penny. And we are gonna make this penny disappear. All right, so I have to adjust things a little here so you can see. All right, okay, there we go. So, there's my penny. Like I said, just a normal penny. Nothing weird about it, just a normal table. Put the penny where you can see it. Now, even if I put a glass on top of the penny, you can still see it, right? It's a little funky, but the penny is clearly still in there, right? Okay. So, there it is. Now, we add some water. Where's the penny? It disappears. At least I hope it disappeared for you. It's a little hard for me to see on camera, and you do have to get the angle of this right. If it's not working for you, sometimes to prevent a reflection, you'll actually need to put something on top of the glass of water. But, at least for me, the penny's disappeared. You can also play around with the amount of water that you've added. And this is also caused by refraction. The water is bouncing the light rays around and bending them in such a way that the light rays that hit the penny never hit your eye. That's how the trick works. So like I said, I hope that you can see it from your angle. But this is called hands-on science because you're supposed to get your hands on and try it at home. And I guarantee you, as long as you play around with how much glass is in the water, and if you have to, put something on top to make sure that the reflection doesn't work against you, you will also be able to make a penny disappear by putting a glass of water on top of it. So, I wish you luck with your own magic tricks and your own experiments. You may also want to try and see what happens if you use a glass that isn't perfectly smoothly curved, or if you use a glass that is square instead of curved like a lens, or if you use something much bigger or much smaller. But that is all the time I have today, so I encourage you to conduct your own experiments and let me know how they go by commenting here. And this video will also be saved to YouTube, so you can check it out there as well. Thank you so much for joining me today in my kitchen. I hope to see everybody again soon. I will be doing hands-on science again next Friday, so I'll have another interesting science concept and hands-on activity you can do with things at home then. Have a great day.